This is Mr. Beck Does Your Homework, AP Physics, Homework 8.3, questions 14 and 15. An ideal gas is compressed to half its original volume while its temperature is held constant. Wow, that doesn't give me much. It doesn't tell me what the volume is. It doesn't tell me how much of the ideal gas I have, so I don't know N, I don't know P, I don't know V. All I know is the temperature is held constant. This sounds like a tough problem. If 1,128 joules of energy is removed from the gas, oh wait, I can do that. That's Q equals negative 1128 joules. How much work is done on the gas? So now I need to know how much work is done on the gas. Well, I do know that U, my change in internal energy, equals Q plus W. So how do I figure out my change in internal energy? Because that would relate these. Now wait a second. My change in internal energy, if my temperature is held constant, this is an isothermal compression. For an isothermal, that means that my temperature, my delta T, is 0. So if I have no change in temperature, how does that relate to delta U? Well, I know that U is 3/2 N kBT. So if this is constant and this is constant and this is constant, well, U is related to the temperature. If the change in temperature is 0, then the change in internal energy is 0. So 0 equals Q plus W. That means that Q equals minus W, or alternately, W equals minus Q. So if Q is negative 1128, then guess what happens to W? W is going to be positive 1128. So all of the energy that was removed from the gas was removed because work was done on the gas to keep the internal energy the same. So now that answers 15 as well. What is the change in internal energy of the gas? Well, guess what? It's got to be 0.